graph again. Question 4. Trolley X, we have two trolleys, trolley X and trolley Y. Trolley X has a mass of 1.2 kg. It is traveling 8 meters per second east, and it collides with trolley Y of mass 0.5 kg initially at rest. So they gave us this graph. Now it's not momentum time graph, it's velocity time graph. So the values given on the y-axis are velocity. So if you look at the graph, you can see trolley X was moving with a velocity of 8 meters per second from 20 seconds. Then when it is at 20.1 second, then you can see the velocity decreases. That's where the collision took place. Okay, and then what happens to the velocity now? It becomes 4. Okay, so first question, state principle of conservation of linear momentum. You know that question. Second question, calculate the magnitude of velocity of trolley Y immediately after collision. So if you get questions like this, it's always better to write X and Y separate so that you can see. Mass of X is 1.2, mass M1 is equal to 1.2 kg, mass of Y, what's the mass of Y? 0.5 kg. From the graph, you can read the velocity, initial and final velocity of X. So initial velocity of X is equal to what? Initial is 4 and after collision it's 8 and 4. Initial is 8 meters per second and final velocity V1 final is equal to 4 meters per second. So there is it is moving to the east. Okay, then they said Y, initial velocity of Y is 0 because it is at rest. So in this case we are calculating what is the final velocity, VF2. That's what we are calculating. Okay, so we can use what? Sigma equation and substitute. Let me write. So after substituting, this is how the equation is. Then you solve for V2F. That's it. Okay, so when you solve for, so you know how to do the solve for V2F. So when you do the calculation, your answer is 9.6 meters per second. Okay, so it shows this is asking for magnitude, so that's why I'm not writing the direction. So the answer is 9.6 meters per second. 8 meters per second. Now next question, 4.2.2, average net force trolley X exerts on Y. So for calculating the average net force, you can either use trolley X or Y. I'm going to use trolley X. Okay, so 4.2.2, F net is equal to delta P over delta T, which is M Vf minus Vi over delta T. Okay, mass of trolley X is 1.2 times final velocity is 4 minus initial velocity is 8 over what is the time? When you look at the time, you can see collision took place from this point to this point. So 20.2 minus 20.1. Okay, so 20.2 minus 20.1. Okay, and then you solve for it and you will get minus 48. Okay, here also they are asking for magnitude, so we are saying what? 48 newtons. Magnitude means we don't need direction. Okay, and the last question, is the collision elastic or inelastic? Explain the answer by using a suitable calculation. To calculate whether the collision is elastic or inelastic, we must always look for EK before and EK after, isn't it so? Because for between elastic and inelastic collision, momentum is conserved in both collisions, but what is not conserved is kinetic energy. So before is half m1 v1 I square plus half m2 v2 I square. Then let's calculate. So this is the answer. So I used the initial velocity of trolley X and trolley Y. So this one is 0. So but we still substitute to show the substitution. So the answer is 38,4 joules. Also you can use, so then you can calculate EK after. So calculating EK after, same equation, half m1, difference is now what? V1 final square plus half m2 v2 final square. Okay, and substitute the values. So you can see this is the substitution for EK after. So this is for the first trolley, X trolley, and this is for trolley Y. This is X and this is Y. Okay, so when you calculate, your answer is 32,64 joules. So now you can see EK before and EK after, they are not equal. Okay, if they are not equal, then how do we conclude? We say EK before is not equal to EK after. So then what type of collision is it? Inelastic collision. Because in inelastic collision, EK before is not equal to what? EK after. Thank you. In this question, you can say in a game of snooker or 8-ball pool, the cue that strikes ball A of mass 0,4 kg as shown in the diagram below. Then A rolls and collides with B, which is 0,3 kg. So if you look at the momentum time graph, there is a small difference in the momentum time graph this time, right? So if you look at the explanation, it says the momentum versus time graph is drawn for ball A from the moment it is struck by the Q, which is 0 seconds, and it leaves the Q, T is equal to T1 seconds. And as it collides with the ball, T is equal to 0,25 seconds. So if you look at the graph, from 0, that's where the Q is striking A, right? So what happens to the momentum? Momentum increases, right? And then from A to B, so this is where the A starts moving, right? As A starts moving, and it collides with B at 0,25, means collision takes place here, right? So what happens between this part? Okay, so you can see there is a momentum is not constant, momentum is decreasing. We'll come back to that question. Okay, so here the first question says define the word the term impulse. All of you know what is impulse. Use the information in the graph to calculate the value of T1 if the force exerted by the Q is 65 newtons. So if the force exerted F net is 65 newtons, what is the value of T1? So the Q and A, that is in contact from here to here, isn't it so? Right, so you have momentum, you have time. So we can actually make use of this graph, because if you take the gradient of this graph, it's equal to what? Gradient is change in y over change in x, right? Change in y over change in x means change in what is on the y axis is momentum over time, right? That's equal to what? F net. Okay, so we can make use of the gradient here. Okay, right. So if you look at it, you can see what is the change in momentum? Final momentum minus initial momentum, 0,95 minus 0 over time is corresponding time is T1, okay, minus 0. That's equal to, they said the F net is equal to what? 65 newtons. So that's equal to 65. Okay, so 0,95 over T1 is equal to 65. Okay, so what is T1? 0,95 over 65 is equal to T1. So when you calculate, you will get, so the answer is 0,0146, which is 0,015 seconds. Okay, right. So now let's go to 4.2.2. Explain why it is correct to say that the table surface is rough. So how can we say that the table surface is, or why it is saying that the table surface is rough? So that's where we can make use of the movement of A. A moves from here to here, isn't it so? And it strikes there at B. While it moves, what happens to the momentum of A? Momentum of A decreases. Usually momentum graph is always like a constant, momentum will not change. But here the momentum decreases, right? So it means what? Momentum P is equal to m times v. No change in the mass of ball A, right? So what changes? If momentum changes means what changes is the velocity, right? So momentum decreases means velocity also decreases. So what makes the velocity to decrease is obviously the friction of the friction of the surface. So that is what you need to explain. Okay, so here we can say between t1 and 0,25 there is a decrease in momentum of ball A, right? That means velocity of the ball decreases, which shows that there is what? Friction. Okay, so that is the answer for the second question. And the last question, calculate the velocity of ball B immediately after collision. So now look at ball B. So ball B initially it was at rest, isn't it? So the ball A hits ball B at this point. Okay, so we have this is the momentum for A, right? So we have the initial momentum for A, which is 0,77, right? And after collision, what is the momentum of A? That is this one. It changes, right? 0,16. So we have the initial and final momentum of A. So these are the informations that we have. So what can we use? Our sigma pi, right? Sigma pi is equal to sigma pf, right? So initial of A plus initial of B is final of A plus final of B, right? So initial of A we have is 0,77 plus what is the initial of B? 0. It was at rest, right? That's equal to final of A is 0,16 plus final of B. So question is not final momentum, question is calculate the final velocity. So we know final momentum means mass times velocity, isn't it so? Or you can calculate final momentum of B and then from there you can substitute. So let's go for that. Okay, so final momentum of B is equal to 0,77 minus 0,16, which is equal to 0,61. Okay, now what is momentum? Momentum of B, B times final velocity of B, that's equal to 0,61. What's the mass of B? 0,30. Okay, so 0,30 times final of B is equal to 0,61. Then divide both sides by 0,30 and you will get the answer. Okay, I got the answer 2,03 meters per second. The question says calculate the velocity. So velocity is a vector quantity. This is the magnitude and what is the direction? Direction is right because we took right as positive, isn't it so? Answer is positive, so right is the direction. Okay, thank you.